দেখছি স্যার একটু।
Yeah. So your mistakes. You
Yes
check
sir.
here. MCQ 9, 10, 19, 20. Huh? 21, 23. Isn't it?
Yes sir. Yes
So
sir.
we have here how many wrong? Six. Six wrong, right?
Yes sir.
Okay, okay. So your one, if Kadir. Yes, 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 yes. 4-2, right? 4-1.
Yes.
So, so this one is very clear. Thank you. And here you have 9, right? 9,
Yes sir.
9. You give C. So 9. What we have the question we see 9. Question number 9. Oh, this one. You read question 9.
In a lighting circuit, the switch is placed in the live wire. Why is this? I give C, which is the switch does not work in the neutral wire.
It's correct. What you said is not wrong. Yeah.
Yes, sir.
Yeah. So they should give it you score, but they actually wanted more appropriate answer, right?
Yes, sir.
They actually want to focus what is the purpose of switch. Yeah. If you put the switch in neutral wire or not putting it there, is the same thing, right? What is the purpose of
Yes,
switch?
sir.
Purpose of
To
switch is
turn on, like the
turn on the
light
circuit,
bulb.
or to turn off the circuit, right? Isn't it?
Yes, sir.
So if we don't have switch, then we can never turn off uh, any of the appliances, right?
Yes, sir.
Isn't it? So what is the purpose of this switch? To break the circuit, right? To
Yes, sir.
without switch, we can have the connection for the day night 24 hours, right? You just connect every appliance with the mains, 24 hours they will run, right? As long as there is electricity they will work. But why we are using switch? So that we can make them work for our need, right? For our necessity.
Yes, sir.
So what is the uh, answer now? Can you guess?
A, I guess. I
Yeah.
think it
So
will be A.
yes, yes. A for appropriate answer, right?
Yes, sir.
This it's not wrong. Your idea is correct, but which one is more appropriate as a function of switch, right? That one we should focus. Okay, now
Yes, sir.
after 9 we have 10 also wrong, right? 10?
Yes, sir.
Yeah, I saw that you have one consequence like sequence 9, 10, 19, 20, right?
Yes, sir.
Yeah. So I observed that. That's why I can remember it is 10. After 9 we have 10. So what is the rule for magnetic field lines? Three rules, right? Number
Yes, sir.
one, number one is magnetic field lines should start from north and end to the south, isn't it?
Yes, sir.
So in your answer you get B, Bangladesh. Let's see. You get correct. It's correct. So
Oh,
you were wrong. You gave it correct. B, Bangladesh, right?
Yes, sir.
So how you got this wrong? Let me check the mark scheme is written wrongly or not. Okay, let me check.
Okay, sir.
Maybe I need some correction in the mark scheme. Hmm. Sometimes it happens, right?
Yes, sir.
Okay, let me check. Final question available. Career coaching mark 2020. Yes. Then we have mark 4. It is 10, right?
Yes, sir.
Uh, yeah, it's given 10B. Why? So I gave wrong which one? BBAAB. Okay. The mark scheme is also
Oh,
showing into Bangladesh. So why I gave that one wrong? Maybe mistakenly, right? Human errors, right?
yes, sir.
Human errors. So human errors can be corrected also. It's now coming 5 wrong, right? So your one is coming now 35. Can you check what is the percentage coming now?
Yes, sir. Sir, 87%, 87.5%.
Oh, 88. MashaAllah, 88%. Well done. Try to make it 90%, huh?
Inshallah, sir. I will try.
So next one is 19. 19 you gave Dhaka. Let's see. 19, what is there? Oh, this one.
Yes, sir.
Okay. So you chose which one? Dhaka.
Yes, sir. I chose Dhaka.
Yeah, in parallel connection, all of them will be same. Yeah, two. If it is in series, then it will be 4 volt. Okay,
Oh, yes.
clear?
Yes, sir. So it will be like 2 volt.
Yes, yes.
So
In
it,
parallel connection. If it is series, then it will be 4 volt. Okay, have you got it?
yes, sir. Like 2 plus 2, 4 volt. And like it's half plus half. That right? And like inverse to get the parallel combined resistance for
No, no,
parallel.
not like that. It's actually the parallel one is not working like that series resistance or parallel resistance. Okay, parallel one. Is it clear?
Oh, yes,
It's
sir.
like
Now I get it.
if you have like 1.45 volt, if you have even 10 10 cells are in parallel, then you will get 1.5 volt only. Okay, you have
Oh,
2
yes, sir.
volt, like not only this two. If you have even six cells are connected together in parallel, you will have still 2 volt. Is it clear now?
Oh, yes, sir. Now I understand. It's like the one's cell will be used at once, right?
Yes. Like it will be last longer. Yeah, the sale will last longer.
Yes,
Okay?
sir.
And we are having in series more voltage. That one will run out quickly. We are having more voltage, more current, and it will run out quickly. Okay, series.
Yes, sir.
In parallel connection, lots of cells together, we are having low voltage, low current, but it will last longer. Okay, so what should be your answer?
It should be C.
C for correct answer, right?
Yes, sir.
Okay, okay. So it's clear now, right? 19.
Yes, sir.
Then which one next? 20. 20 you gave Bangladesh. 20, what is that? Okay, 20. You gave, you gave Bangladesh.
Bangladesh.
How,
Yes, sir.
how, how you got this Bangladesh? Can you explain?
Um, sir, as only the switch R will be open, so like Q and P will be closed.
Mhm.
So like it should be 0.1 into 8, then plus 0.4 into 8 again, because 8 cents are like for per kilowatt hour, and like I'm using it for like heater. The fan motor is connected to the switch, so it should go like 0.1 into 8, and then
Okay,
like
okay, okay, okay.
the
Can you
yes.
annotate? Can you annotate? I allowed you to annotate. Okay, what you said? Can you annotate? Are you in laptop or phone?
So I'm on the laptop, but there's like no annotating option over here, because like it doesn't work over here for some reason. I tried to do it in other classes though, and it also didn't work there. Like the option is freezed in my laptop for some reason.
Uh, okay. So what to do then? What to do then? You can you can
Yes, sir.
okay. You can explain again. No problem. Then. I thought that you can write it anyway. So we are having in fan motor 0.1, right?
Yes, sir.
And we are having in the Q Q switch. They are
For the
saying
heaters.
yeah,
Yeah.
P and Q close. That means Q heater. This one is working, but R is not working. So zero
Yes,
point
sir.
0.1 and 0.4. How much is coming? 0.5, right?
So why will we added uh
Okay. Okay. Very good question. Here is the power rating, right?
yes, sir.
Power of the fan, power of the heater. So we are having one fan and one heater working. So if you have more, you will add that one also, right? So you are adding actually in the whole circuit how much power is consumed. Okay.
Yes, sir.
So how much power is consumed? The total power we are going to have add or sum of. So in our two devices, we have total power consumed 0.5 kilowatt hour. Huh? So
Yes, sir.
this kilowatt hour, that means in 1 hour, that amount of energy is, if it is 2 hours, uh, if we have 2 hours, if you multiply with this 0.5 with 2 hours is coming energy. It's no more power, now energy, right? multiply
Yes,
with
sir.
time. So your 2 hours is running these two devices. It's showing our energy is here 1 kilowatt hour. 1 kilowatt hour for 2 hours, right?
Yes, sir.
So 1 kilowatt hour costs 8 cents. Okay, 1 kilowatt hour cost 8 cents is given, right? In the first sentence. Here, just below the diagram. Cost of electricity
Yes,
is
sir.
8 cents per kilowatt hour. So we have 1 kilowatt hour totally the energy consumed, and per kilowatt hour is the cost is 8 cents. So our answer is 8 cents.
8 cents. Oh.
It's clear now? Is it
Oh,
clear?
yes, sir. Yes, sir. It's I now understand it. Yeah.
Okay, okay. So we are done with 20, right? We are done with
Yes,
20.
sir.
Very good. Now, after 20, we have 21 and 23.
21, 23. Yes, sir.
21, you give Dhaka. Let's see, 21. Okay, can you read 21?
Yes, sir. Why are the metal casings of electrical appliances earth? I gave D, which is to protect the appliance from overheating.
Okay, okay. So listen, we have three things. For safety purposes, we use three things. One is fuse, another one is circuit breaker, another one is earth wire, right?
Yes, sir.
So fuse we use normally in appliances, right? So that if there is more electric current flow through the appliance, the fuse cut, then circuit incomplete, then our appliance or device is protected from overheating, right? Catching fire. Is it clear?
Yes, sir.
Is it clear? Uh, so this one is about overheating or catching fire that is related to fuse. Again, come to circuit breaker. If your fuse is blowing or fuse is cut, then we replace the fuse, right? Isn't it?
Yes, sir.
And
Yes.
circuit breaker normally we get for the house wiring, right? The complete house or a flat or a total building. For them, we are using the circuit breaker, right? Isn't it?
Yes, sir.
And circuit breaker, how it's working? If there is more current flow, then circuit breakers breaks the circuit, right? By resetting the circuit breaker, we can have
We can
again
get the
connection
original.
again,
Yes, sir.
connection
Yes, sir.
again. So
Yeah.
we do not need to replace the circuit breaker, right? And
Yes, sir. Like
circuit
it is
breaker,
easier for circuit breaker,
yeah,
right,
and
sir?
circuit, yeah, and we just reset it, right? Uh, Reset the
Yes,
circuit
sir.
breaker, and we are using circuit breaker for a little bit larger scale, and fuse is only for small appliances, right? Separate appliances.
Yes, sir.
So you understood it, right? What is the difference between fuse and circuit breaker? The function is almost same. It's protecting the uh, circuit or the appliance from overheating or catching fire, right? Isn't it? In circuit breaker
Yes, sir.
also, if there is too much flow in the whole, flat or a single room, then there might be possibility of catching fire due to high current, right? Overflow of current.
Yes, sir.
So this
Yeah.
circuit breaker and the fuse are working in the similar way. Though there is some little bit difference in action and their place to work, right? Isn't it? Hello.
Yes, sir.
Now, earthware. Earthware is used for the appliances where we have uh, metal casing. Yeah. In metal casing, we have possibility to pump electricity or deposit charges, right? If we touch it,
Yes, sir. Mm.
then there might be a possibility of getting electric shock, isn't it?
Yes,
Isn't
sir.
it?
Yeah.
So to avoid this, we connect the metal surface with the earthware so that extra charges, extra current flow can go through that wire to the ground. And if we are touching it on the surface of the appliance, then there will be no harm, right? Isn't it?
Yes, sir.
So uh,
Yes, sir.
we are using 3-pin plug in the appliances which have metal surfaces. Okay, like refrigerator or oven. Okay, so
Yeah.
these kinds of like any sort of these kinds of appliances we are using the in the washing machine, right? Washing machine. So sometimes we have the metal surface. That time we are using PVC. But uh, which one we have plastic cover. We do not need three-pin plug. We do not need to make it arc. That is called double insulation, right?
Yes, sir.
Yes.
Like the
So
hair dryer,
yeah,
right, sir?
here then some ironer also we are using with plastic cover, right?
Yes, sir.
So do
Yes,
not
sir.
need their earthware or three-pin plug. So now you understand what should be our answer.
Sir, I think it should be B.
Bangladesh,
Yes,
right?
sir.
To ensure the casing is not at a dangerous voltage. Correct, correct, correct. You are now
Yes,
correct.
sir.
So our explanation worked, right?
Yes, sir.
It's showing the learner's correct way to use, right? Isn't it? 23.
Yes. I give B. Yes, sir.
Yeah, Bangladesh you gave. So let's go. 23. Yeah, which action demagnetizes a bar magnet? You gave Bangladesh. Placing the magnet inside a coil connected to AC. Yes, so if you place it, then continue the current flow. And then if you uh, keep it over there, then it's not permanently demagnetizes. Like it's demagnetizes, again magnetizes, again demagnetizes, magnetizes. This way it's going, right? But if you withdraw,
Yes, sir.
yeah, withdrawing the magnet from inside the coil connected to the AC supply, that time we will have completely demagnetization. Okay, slowly we should
Oh,
withdraw the
yes, sir.
magnet, and it's written in your book. Check method of demagnetization. In your book,
Mhm. Yes, sir.
one you say federal physics book, that one, or you say O level course for O level. It's written Charles Chew, written by Charles Chew. Check the green color one. You have right that book.
Yes, sir. Federals, right, sir?
Yeah. So you
I
have
have
it,
that one.
right?
Yes.
Yeah. So in that book we have this discussion. Okay, you can get it over there.
Yes, sir.
Should I show you?
So the answer will be D.
Yes, should I show
Right, sir?
show you that one? Should I?
Sir, I have the book.
Have the book. Now you can find it.
Yes, sir.
You can find it now.
Yes, sir.
Yeah, which page can you tell me?
Sir, that page. Let me sir check for a
Yeah,
while. Which
check
page?
and tell me. The page you tell me, please.
Yes, sir. Um, I'm checking. Um, sir, it is 338.
338.
Methods
So,
of.
yeah, what
Yes,
is
sir.
written there? What is written there? Can you read?
Sir, it is written methods of demagnetizing magnets.
Hmm.
Number one, heating. Number two, hammering. Number three, alternating current. In this part, they have written this is the most efficient method of demagnetization by placing the magnet inside a solenoid connected to an alternating current supply. The magnet is slowly removed with alternating current flowing in the solenoid.
So, got it?
Yes, sir.
Okay, thank you. Thank you so much. We are done with this part, right? Paper one. Huh?
Yes, sir.
Let's go for paper two. State the material. Can you read loudly, please, that I can understand
Yes, sir. State the
quickly.
material from which the compass needle is made. I give iron. Then B. Describe how the small compass is used to plot magnetic field lines in the region surrounding the magnet. We will bring compass near the one end of the pole and mark the pointer's direction with the dot. With the dot, we place the magnet on the dot and repeat the process until they reach the other pole. Then join all the lines to draw a magnetic field. Repeat the repeat the entire process to produce more magnetic field lines.
Very good. So, part B, you are getting marks. Part A, you should make a correction. It should be steel or cobalt or nickel, right? Because compass is made from the hard magnetic material. Compass is a permanent magnet, right? With iron,
Yes, sir.
iron is soft magnetic material. You cannot use iron to make permanent magnet like compass. Clear?
Oh, yes, sir. Now I get it. Like in
Okay.
the compass, we need permanent magnet.
So you give here just one circle over your writing, and beside it you write still, and here give -1.
Yes, sir.
Clear?
Yes, sir.
Mhm. So continue this quickly.
Iron is the magnetic material. When magnet move towards it, the magnetic field of the magnet is around the iron bar, causing a magnetic force to act on it, causing the iron bar to get attracted to the magnet.
Okay, so here we are having the first thing, we are having here induced magnetism, right? The iron bar.
Yes, sir.
So you brought that idea, you wrote causes a magnetic force to act on it, right? And
Yes,
then
sir.
you write causing iron bar to get attracted to the magnet. So we
Yes, sir.
when we are having this magnetic force, that time at P we are having North Pole, right? At P we are getting North
So,
Pole. If we are having
yes, sir.
induced magnetism and unlike poles attract, unlike poles attract.
Like positive.
Yeah, so this way you should represent your answer, right? So
Yes, sir. So, I should write induced magnet, North Pole, and unlike poles attract.
yes, yes. So here we can give you one minus to you right here.
Yes, sir.
So have you written action?
Yes, sir.
Keep your answer.
-2.
Yeah, you keep your
Yes.
answer and you write the points we have. It's space here, right? Anywhere you can write. So
Yes.
have you written the points? Writing the points is very important. Have you written?
Yes, sir. I have written. Yes, sir.
Very good. Very good. Then question two, you got 4 ohm, right? 4 ohm, 1.5 ohm.
Yes, sir.
Hmm, 4 ohm, 1.5 ampere. Correct. Your answer is correct. Then we are going to state what is meant by the amount of energy. What you wrote, can you say? Can you read?
Yes, sir.
Um,
The amount of energy converted from electrical to non-electrical when one coulomb of charge passes across a component in a circuit.
okay, you wrote 1 coulomb, right?
Yes, sir.
Uh, Potential difference, huh? Electrical to other forms, huh? Correct. Then
Yes, sir.
add to figure 2 and the symbol for the component that is measuring here we need the
The symbol of the voltmeter
yes,
symbol.
equals to 1.8. Correct. Okay, then next the resistance of X
Uh,
is increased.
Voltage differs, but the current remains same in series circuit. So when X increases, so PD across 2.8 ohm, the 2.8 ohm decreases. Is it okay?
Explain why the potential difference across the 2.8 ohm resistor decreases. Voltage differs but current remains same in series, right?
Yes, sir.
Not series circuit. Okay. Yeah, voltage is better to write voltage is shared. Voltage is shared.
Oh, yes, sir.
Voltage is shared,
Voltage
but
is shared.
current
Yes, sir.
remains same in series circuit. So
Mhm.
when X increases, potential difference across 2.0. No, it's not enough. We have to
Oh,
go for more uh, depth idea. Like here we have look, we have here this one x, right? It
yes, sir.
is x. So x, uh, for example, I am giving you one simple idea or simple example. Like if the value of x is now 3.6, for example, like now, not increased. Before increasing, it is 3.6. And then your uh, total resistance or combined resistance of this arrangement, the parallel one, how much it
Yes, sir.
is? How much it is?
3.6.
3.6. No, parallel arrangement, it will be 3.6 or it will be 1.8. Like if x is
Um,
3.6, then
yes, sir.
what will be the resistance in this arrangement? 1 point,
The total resistance.
yeah, total resistance. Only this parallel part.
Yes, sir.
Yeah.
Uh, I'm calculating it. So, so it will be 1.8. Yes,
Yes, it
sir.
is 1.8. I already told you. If
Yes, sir.
now,
Yes.
if now, for example, I am not using 3.6, I increased it. I increased it to 5 ohm. X is now
Yes,
how
sir.
much? 5 ohm. So
5 ohms.
then what will be your resistance? Combined resistance.
So it is 2.09.
2.09,
Uh,
and we understand it's more than before, right?
yes, sir.
So our parallel arrangement, if we increase the resistance of any of the resistor, then combined resistance increases. That one we got the proof, right? From
Yes,
this
sir.
example. And if we get here more resistance than before, then the voltage sharing will be also more than before, right?
Yes, sir.
This
Yeah.
one you might not understand because I'm not sure that you are clear about potential divider rule or not. Like if we have here 6 volt, for example, it is 6 volt,
Yes, sir.
right? So it is 2.8, it is 1.8. The example I gave you at the
Yes.
beginning, 3.6, 3.6, then it is 2.8, then this one is 1.8, right? So
Yes, sir.
how much voltage will be shared in 2.8? We already said that if the resistor are in series, then they are sharing the voltage, right?
Yes, sir.
So
So
this is what
2.8 will have more voltage.
2.8 will have more, and that 1.8 will have less. How
Yes,
much
yes, sir.
less? We can also calculate by using the
Calculate.
formula.
Yes, sir.
Yeah, like V1 equals R1 by R1 plus R2 into V. That formula we can use, right?
Yes, sir. Yeah.
Or also you can find V2 same way, right? Now,
Yes, sir.
now we are clear about one thing that 2.8 and 1.8. So 2.8 will take more voltage than before, isn't it? Now the next example where I told that X is now 5 ohm. That time
Yes,
your
sir.
combined resistance 2, right? 2 ohms. 2
Yeah.
point 2.09.
2.09
That
ohms.
means we can say 2.1 or 2 ohms, right? Very small.
Yes, sir.
So 2 ohms, that one is now more resistance than before, right?
Yes, sir.
So if it has more resistance than before, that means its sharing is more than before now, right? Like when it was 1.8, the amount of voltage is shared. Now 2 ohm, it will share more than before, right? Isn't it?
Yes, sir. Yes.
Do you agree?
Yes, sir.
Okay. Then, if it is sharing more voltage than before, this parallel combination, the 2.8 resistor, it will share less than before, right?
Yes. Yes, sir.
If it is sharing
Yeah.
less than before, then we say voltmeter reading decreases, is it?
Oh, yes, sir.
Now we have to write this way. We have to bring this idea that if X increases, then the combined resistance in parallel connection,
Increases.
yeah, increases.
Yeah.
Hence,
Yeah.
2.8 2.8 ohm resistor in sharing decreases, right? Yeah. As a result,
Yes, sir.
voltmeter reading decreases. This way you have to write. Anyway, I would give you 1 mark here. Hmm.
Yes, sir. Sir, I will write so 2.8 ohm resistor uh, voltage decreases, so voltmeter reading also decreases.
Again say
Uh,
no. You
sir,
you bring
I'm
you
writing.
bring you bring that idea.
Yeah,
If X increases,
X
then
increases
parallel combination
combined
current.
resistance.
Yeah, parallel
Oh,
combination resistance increases.
resistance.
This one you have to mention. This is first point. Yeah. Then second point, you are getting that one. Uh, the voltage sharing in 2.8 ohm decreases. Okay.
Yes, sir. Yes, sir. Written.
You have written, so you give here -1, huh?
Yes, sir.
3. Now we are going to question 3. Okay. So how many questions we have? 3, then 4, 5, 6. How many total question? 6
Yes, sir.
or 9 questions. Oh, 9 questions.
Oh, nine.
6. After that, 9.
Uh, wait.
Huh?
Uh,
Was was there anything missing here?
so let me check.
Yeah, yeah.
Oh,
Okay.
I missed 7 and 8. Oh no.
Oh, okay, okay. So you
uh,
you just send me
yes, sir.
now. You just send me now those pages
Yes,
you
I'm
missed. Huh?
sending.
Yeah, yeah. So we have a break, huh? Break, huh?
Yes, sir.
10 minutes break, huh?